Now I'm going to be asking a few questions, which are important in making sure that you understand the basic concepts of this presentation. Which one of the factors below is not taken into account while determining the estimated glomerular filtration rate? So A is age, B is creatinine levels, C sex, whether or not you're a Nazi, E none of the above. So I don't know if you remember this earlier slides, but we talked about how the glomerular filtration rate is estimated. We said that we use several equations. These equations take into account lots of things. Yes, ages indeed was one of them. Creatinine levels was definitely one of them. Your doctor must order a blood test to see the level of creatinine in your blood. Again, whether or not you're a female or a male, that was also very important. And D is whether or not you're a Nazi. This is also it's basically a word play. If you're a Nazi, we know that you would be an Aryan. That means that this is your race. Hence, race is also taken into account. Therefore, the answer to this is E, none of the above. So, second question, how is the pressure gradient created in hemodialysis? So we mentioned that to ease the filtration procedure, we do create a pressure gradient. Now we'll be talking about, now the question is asking, how do you do that? A, by speeding up the blood flow from the patient. Well, not really, it's not something that we can do. We can make the patient's heartbeat faster, or speeding up the blood might cause problems directly if you do that. B, by administering heparin to the blood taken out of the patient. Heparin is basically a blood thinner. Doing that is again also going to cause problems if you do it more than necessary. C, by saying "Neytika'dan gidiyor" to their face. That would definitely get their blood pressure up, but I don't think it would be enough to do that. D, by having opposing fluid flow inside the dialyzer. This was what we said before. The pressure gradient is acquired by having opposing liquid flows on either side of the synthetic porous membrane inside the dialyzer, and this helps with the filtration procedure. And E, certainly not by changing the diameter of the tubing. So, what function does the filter in peritoneal dialysis? A, imam power. B, peritoneum. C, cell membranes. D, diaphragm. E, synthetic membrane. I mean, it's kind of also is in the name. Peritoneal dialysis takes advantage of the membrane inside your body, which is called peritoneum. Yes, we have a question about the history of the dialysis. Who successfully undertook the first dialysis on humans? A, Wilhelm Johann Kolff. B, Max Planck. C, Alexander von Humboldt. D, Abdülhamit II, also known as Ulu Hakan. E, Ramanika Hall. Well, we mentioned that it was a Dutch scientist named Wilhelm Johann Kolff, and the other guys certainly have nothing to do with dialysis. One of them is a neuroscientist, the other one is an explorer, naturalist, and one of them is a physicist. The other one is a sultan for the Ottoman Empire, who's beloved by the conservative people in Turkey. 5. Which one below is the non-electrolyte component of the dialysate solution for hemodialysis? Well, we mentioned that there are lots of different ions inside the dialysate, which included calcium, which included other ions, and there was also one that was non-electrolyte, and it is not actually always put inside. It's not always prescribed by the doctor to be added into the dialysate solution we mentioned. glycine, B, dextrose, C, EDTA, D, trypsin, E, acetylcholine. So glycine is an amino acid. B, dextrose is our answer. EDTA is something completely irrelevant. D, trypsin is an enzyme that digests the cell outer layers that attaches to the surface of surfaces. And E is a neurotransmitter, which has nothing to do with this topic. Sixth question. There are two ways that a solenoid valve can shut off the flow of a fluid. What are the differences in the ways that they achieve this? So this question is actually something that we didn't really give you the exact knowledge to be able to answer it, but having a background in physics and also electromagnetics should give you the insight into this question. So let's go through the question. What are the differences in the ways that they achieve this? So it talks about solenoid valves having different ways of operating, two different ways of operating. Let's go through the options. A, they use different materials as wiring with different resistance values. Anyone with a good physics background would know that and after having gone through our slides, would say that changing the resistance values wouldn't really cause anything in terms of operating differently. B, the wiring is heated or cooled depending on the system. Yes, we did talk about thermistors having different resistance values in temperature differences, but again, this would have nothing to do with the different ways of operating. The change in the direction of the current changes the direction that the spring moves. As you remember, we in the solenoid valve systems, we would have a spring and we would have a plunger that surrounds the spring. And so in the example that I gave, actually, I'm going to go back to that that slide, and maybe it would help us understand the situation better. So, yes, as you can see, we have this spring here and the plunger here, and we know that if, in this case, this is a closed valve. In this case, if we know that if there's current that would come here, the electromagnetic field would push the plunger up, hence allowing the fluid to pass. And here is the open valve. So one thing to keep in mind is we remember this rule from the past in the first year of college, also in high school. We know that there's this thing called sahil kuralı, and we know that this actually shows us in which way the electromagnetic field affects something inside it. So, as you can see, the direction of the way the spring will push the plunger is dependent on the current direction. So, right now, the current direction enables the spring to push the plunger upward in an upwards direction. But if we were to change the direction of the current, it would cause the valve to work in a different way. It would not really, in fact, it would actually make it work in the opposite manner compared to this. So that is actually going to be our answer. Yes. The change in the direction of the current changes the direction that the spring moves. Well, this is another option, which certainly isn't. One of them is approved by the Diyanet Işleri, it is halal, the other isn't. Hence, it makes all the difference. It does not make any difference at all, unfortunately. E, spring that pushes the plunger, is basically made with a tougher material that doesn't work as fast. Being tough has nothing to do with this. So let's go on to the other question, seventh question. So this is a question about the peritoneal dialysis. So peritoneal dialysis has several steps involving ... and ... So this was Yusuf's slide. As you remember, there are several steps that need to be accomplished. It works completely different compared to the hemodialysis and hemofiltration. So, yes, let's see the answers. Hooking up, diffusion, and drainage. So basically what happens is you first have to have a cannula going through your abdomen. This is obviously done surgically, and there's what I mean by cannula is basically a small tube that's going into your stomach. And then there's the diffusion part. This is the part where your body removes the waste products by interacting with the liquid inside, the liquid that's filling your stomach. And then the drainage. Obviously, you have to take out the waste products that are filtered out of your body. And this is the William II, the Kaiser of Germany. The solenoid valves are widely used in the industry because they enable something. So, again, these questions are also prepared to make sure that you learn by doing questions as well. We did not mention about this in the solenoid section, but basically the procedure that the solenoid valves undertake, they can be done with physical valves as well. The ones that are old school, the ones that are closed, like shut off, and like turned on, but they are not used that way because we want precision. If we want something that was like that, like physical, that we cannot really close it or open it easily, then it's going to be problematic, especially in a procedure that requires precision, as dialysis does. So the answer is digital and precise control. You can use a computer to let the current get to the spring and manipulate the plunger in the way that you want. Yes. So the ninth question: the temperature of the fluid going in the dialysis machine is controlled via the something. We mentioned about this in the second component or third component of the hemodialysis components. It is the thermistor feedback circuit. Thermistor is a circuit component that is widely used as in purposes that involve controlling of the temperature and keeping it in check. So thermistor feedback circuit is also used in dialysis. So the 10th question, and this is the last one that we're going to be doing in this presentation. What are the chemical agents used for balancing the acid-base levels in both hemo and peritoneal dialysis? A. Phosphate buffered saline, heparin. B. HEPES, trypsin. C. Bicarbonate and lactate. D. Calcium, potassium. E. Cystine, controllium. So, heparin is mainly used in hemodialysis for preventing clotting of the blood. That would cause patient some problems. Phosphate buffer saline is something that is used widely in biomedical research laboratories. It has nothing to do with this situation. HEPES and trypsin, this is an enzyme, this is a buffer that is in a specific pH range, but again, it's not used in dialysis. C is the right answer here. We mentioned that bicarbonate is used as in hemodialysis to balance the pH levels, and lactate is its counterpart in the peritoneal dialysis procedures, again to balance the pH. D is calcium and potassium. We know that these have nothing to do with pH levels. And E is obviously reference to one of our